Also, the quality is improving enough that you get
so
results.
you can do fit and function test.
Nice.
You can feel it, you can check it. Manufacturing feasibility you can even test. So a lot of good things coming out of those. But yeah, seeing the car first time on the line and being built, it's a good feeling.
By the way, I never understood such kind of stickers on a prototype car, because it basically highlights that this is a prototype car and you should look and you should be curious. So
but
does it actually hide something?
It hides the shape. Yeah, it does. Really.
I mean, it's difficult to really reveal the details of the shape. I mean, I guess the large part of the car is going to be still visible, but at least the design highlights.
You cannot drive an unhided car on the roads, because then
you reveal everything before.
It's not a secret anymore. As a lead engineer, you need to be. Sometimes you need to know how to solve problems. Problem solving skills are quite important. So if you need to drill something on the part, you need to drill something on the part, and you need to know how to do that and with what to do that. So it's not only, as I said, it's not just sitting in front of the computer making models. You also need to know how to use the tools.
So hello and welcome everyone once again to another special episode of Behind the Blueprint podcast.
Every episode is special.
Exactly. Yes. So at some point they will become unspecial if all of them are special. We have two very special guests here with us in the studio. They are our first guests actually from an automotive OEM who has an office here in Hungary. Richárd, Bartalos and Viktor, Bihari. Welcome, guys.
Welcome.
It's very nice to be here.
Thanks so much for coming.
Although I wonder if it's technically true that they are the first one as an OEM employee here.
Well, let's not get lost in those technicalities. But as guests, they are the first ones from an OEM, and that cannot be argued with.
Barna.
He was here in his university title, so
you can explain it. Okay.
I can explain my way out of everything. We have a very exciting topic today because we will take a look into what you have been doing in your positions at JLR Budapest, and this will be a very interesting look and talk for us because. So far, we have had some guests who are working at tier 1 suppliers, but not at OEMs of an automotive manufacturer. And this is the first glimpse that we will take into the OEM world of product development. But before we delve into that, I think we should let our guests introduce themselves.
My name is Viktor Bihari. As I said, it's very nice to be here. Just a few words about me and why I'm here today, basically. I always wanted to work with cars. And looking at that Lego on the table, it pretty much reminds me to my childhood because when I was a child, every Christmas I got a Lego. And that was basically my routine for Christmas to build that Lego. So it's...
Did you do the same thing that I did, that you shook all of the boxes that were under the Christmas tree and whichever one sounded like Lego, you started with that?
Yeah.
Okay,
I didn't really care about the others.
Yeah. My parents really like that quality of me.
Yeah, exactly. So it's very nice to see that Lego here. I still like Legos, to be honest. So that's where everything started about cars. And then obviously when I grew up, I started to... work with real cars, and then I graduated as a vehicle engineer. Before the graduation, I started. I applied to dual studies when I was in the college. It means basically first part of your university you study, and then in the exam period you work as well. So that's where I got the opportunity to work for SMR Hungary as a trainee. It was a great opportunity because I got an experience about how it looks like to design a part. We worked with exterior mirrors. they are very underrated components, to be honest, because they, from outside they look very basic. It's just a mirror with some covers, that's it. But from inside there is a lot of technology and it's quite complex. So it was a very good experience for me. I was part of the Mercedes S-Class team. So it was...
So started high then.
Yeah.
High up in the food chain.
Absolutely.
Yeah, the mirrors are those parts which when they're on the car, they're nothing special, but everybody notices when something is not designed properly about them, because then they make noises and then they vibrate and then it's really easy to notice. So a lot of thinking goes behind that.
Exactly. And when you take off the cover, you see all the technology inside, all the functions like GPS, things like that. So a lot of things. And then in 2019, I got the opportunity to join to JLR Hungary. It was very soon after the office was opened. So I was one of the first product engineers in the office, and I joined as a lead engineer. I started to work on the new Land Rover Defender as a interior door trim and door access system engineer. I was responsible of the delivery of those parts and development of those parts. And then I continued to work on the Discovery and Defender as a model leader, and then later a product owner. And beginning of this year, I was promoted to be the chapter lead or group lead for the exterior team.
How big is the team that you are leading?
Currently 14 engineers, lead engineers and design engineers together. It's a very good team, very nice to work with them.
In which stage was the Defender project when you have joined JLR Hungary?
It was basically when all the it was at the end of the virtual development and starting of the physical testing phase, basically when you get the first of tool parts and or proto parts.
It's a very exciting place to join a project.
It's really exciting, yes.
That's when everything is realized, and then you'll see if it worked out in the CAD world into the real world.
Yeah, because in CAD, although we do a lot of virtual validation like CAE, but it's important to do the validation physically as well, not only in front of the computer and not only in simulations. So yeah, that was a challenging time for me, also because it's very different to work for a supplier and for an OEM, because when I worked for a supplier, I didn't feel that I'm part of the vehicle team, or but when I joined the JLR and started to work on the Defender, I felt that we are building cars and we are developing cars, not only
it's a different mindset,
system or components. And just a few things about my passions. I have a project car, a BMW 5 Series. It's more than 40 years old. I bought it 10 years ago, still not running. So
that's a long-term project.
Give it time.
It's a long project.
But the Defender is running, so
it's running. Yeah,
Well, you've had your priorities straight.
Yes.
Unlike me.
Yeah, so great. I think that's shortly about me.
Perfect. Yeah, we'll touch upon a number of topics that you have mentioned later on, but we want to hear from your colleague as well.
So I am Richárd Bartalos. I'm the match pair of Viktor Bihari in the body engineering team. I'm the chapter lead, or you can call it group lead, for the interior trim mechanical design. I've joined JLR 4.5 years ago as a seating lead engineer. So I was doing the same what Viktor did for doors, but on seats. Before that, I was working at Bosch, working on sensor housings. So
also in Budapest, or
in Budapest, in the development center. So I had my connection to the automotive because we were working on all kind of automotive sensors for multiple OEMs. I've also got my background because, as many of us, my father was like. He's not a car mechanic, but he was working on everything.
He was fixing the cars at home.
Everything, yes. So I had the background why I chose automotive. My passions are cycling, and quite recently I learned roller skating with my wife. So that's a new hobby.
Well, you have to let your hair down a little bit.
I need to, and I'm trying not to crush myself. and whenever we got the chance, we are traveling. So that's really me.
I guess a sense of adventurousness is also an advantage when you're working on products like this.
Yes,
because then you understand the sort of the mindset of the
absolutely
of the customers.
When you have the chance to go off road and try your own product, that's a nice feeling. That's a nice feeling.
Have you already had the chance to try out the new Defender?
Yes.
Yeah, it's a pretty amazing car.
It is. It's really agile. It's really
agile. Wow. Okay. That's,
yes.
That wouldn't be the first thing. I mean, don't get me wrong. It's amazing, but it wouldn't be the first thing that springs to my mind when I look at it.
The good thing about that, it's agile off-road and on-road as well. So.
And have you had the chance to try out the extreme driving conditions with it, like hardcore off-road and steep ramps? And
yes.
Not as a driver, as a passenger.
Okay. Myself as a driver as well. We got the manufacturing plant of the Defender in Nyitra, and next to that there is a quite nice hill. And there you got the chance to put it off-road and let's
great. And since you have mentioned you are the pair of Viktor basically, and mentioned the door, is the door really a borderline between your work? So for example, if we speak about the door itself, you are designing the outside part and you are designing the inside part of it, or how does it connect?
Not entirely.
So how it is split between me and Richie is that if you look at the car, our team is working on everything which is outside, basically every exterior trim, bumpers, for example, front, rear bumpers, doors, including a door as a system, not only exterior but as a system.
Yeah, this is why I asked the door specifically, because it has
it has
an inside and
so
outside as
it
well.
belongs to the exterior team, although it has an interior part as well. And leads, body structures also, I think, and lot of nice parts. And from the interior point of view,
actually we got slides a bit later, so we
can go into that later on. Yes, but before we delve into actually this V model, which is very well known, I've just realized that we also, I think, should put JLR Budapest into context a little bit, because we now understand what your role is in the organization, but sort of just tell us a little bit about the history of how it was, how the whole process developed that JLR ended up having an engineering office here in Budapest.
You mentioned they are the first OEM here as West, but I'm sure that JLR is the first OEM having an R&D center in Budapest. So that's
yes,
I think it's unique at the moment. The office was opened in end of 2018, and main reasons were basically because of the skills in Budapest, engineering skills within the Hungarian and Budapest location, basically. The other advantage of Budapest is that Nyitra, the manufacturing plant for the Defender and Discovery, is very close. It's about less than 200 kilometers, so it's easy to travel there. And then also we have a manufacturing plant in Graz, where Jaguar I-Pace and E-Pace is produced.
Really?
So that's
by Magnus Tire. So
it's a cooperation.
Yes, it's a cooperation. So that's also close, and not to mention the supplier base, tier 1, tier 2 supplier base.
In whole of Central Europe, let's say, because Slovakia, also Hungary, Austria, in Germany, we got lots of suppliers. So we are quite close to them. So we can call this Budapest site as a hub. We got multiple functions here, like supplier technical assistance, logistics, purchasing, the body and chassis engineering as well, electrical engineering. So lots of functions here, covering the whole Central European area. So manufacturing sites and suppliers as well.
It's very nice. It sounds like the whole development chain is also included in the location.
Yes, and when I joined, it was, I think, about 20 people in the office.
Yeah, I was just going to ask how many of you are there right now, because I know a number of my friends who have joined JLR quite recently, so I guess that the team has been growing steadily.
Yeah, so it was about 20 employees in total at that time, and we increased more than... Now I think it's more than 300.
Yeah, it's between 300 and 400 people.
Yeah.
And are you planning to grow more, or?
Yes, it's in the plans. we'll see what are the possibilities. Yes.
But that's already and so this 300 to 400 people are all in the development, or this includes also purchasing and
yes,
so everyone,
includes all the functions.
So the whole office.
Let's say we belong to body chassis engineering.
Yep.
We too in body engineering, and that's over 100 people, 120-ish.
Yeah.
Now I don't know the exact number, but around that, yeah.
I mean, this might be just a really rudimentary question to ask, but where is the office located within Budapest?
Váci út,
Okay.
close to the Gönc Árpád Centrum, I think it's called.
Yeah.
There's quite a bit of offices there, so I guess that made sense to set up.
In the GTC White House, actually.
Okay, that sort of puts our guests and JLR Budapest itself into context, but we are not specifically here to talk with two engineers about the company that they work at, but we are much more interested in the product itself. And by the small hint that we have placed here on the table, we're going to be talking about the Defender and basically the contributions of the Budapest office to the Defender project. Where we thought we would start with is basically to delve a little bit into this whole project, what it means to bring an automotive product to life, and how these whole development stages look like. Maybe if we could start, where does an automotive project start at?
Well, I think we need to start that it's you need to think long term, because it's not a 1 year, 2 year project. It's depends on the content, but if we are talking about a new development, it can take 4 to 5 years, and then obviously the serial production as well, which another 5 years. Depends on the
model cycles, but
yes.
I mean,
So
you're thinking in 5 to 10 years, basically.
Yeah.
Even more, let's say.
Yeah.
So it's a really long project, and that's why it's a nice opportunity to talk a little bit about, because people are using the cars, people are playing with the cars, people are seeing the cars, but they don't exactly know how much effort the engineers have in the development.
Not just the effort, I think, but the sheer complexity of the problem. So
Yes.
I think,
for example, just for context, do you know a rough number that how many different parts does the car have, or how many different suppliers do you have actually?
It's a very... I can talk about, for example, the doors, or Richie can talk about the seats.
Mm-hmm.
It's difficult to say an exact number about the car.
Of course, not an exact, but the order of magnitude.
Thousands.
More than thousands. It's
probably in the order of 10,000. Yeah.
Yes.
Yeah, depends really on the complexity of the car and which model you're talking about.
I can completely agree with that, because I think that there are so many cars, and it's become such an essential part of our lives that really the end users don't really think about how the whole product came to life. They just use it and they complain that it's loud at 200 kilometers an hour, but they don't really know what's behind the whole thing. That it's only becoming loud at 200 kilometers an hour.
Yeah,
so,
and it's pretty amazing that all these lot of parts, thousands of parts, they need to be in the production line at the same time to be able to build the car. So it has a lot of logistic as well involved, and it's a pretty complex system and process. So I think we should start at the beginning. Basically, everything starts with an idea, obviously.
Yes.
So once you have an idea,
let's call it vision. That sounds better.
Yeah, a vision or an idea. It's you need a lot of input for that. You need some marketing feedback or customer feedback, engineering feedback. All the departments sit together, do some brainstorming about it.
So it's not just the one guy who has a bright idea in the pub.
No, I think
and says that, hey, we should make this.
No, it's a teamwork. Cars are not one man.
One man shows.
Yeah, it isn't. So it starts about a vision, and then writing requirements, which you can see on the left side as well. So once we have a clear requirement, what the product should look like, how should it function, which market it should be sold, for example, capacity of the car, all these things, then it's part of the development as well. But after that, after all these requirements are agreed, that's when the real development. That's when most of the engineers gets involved into the development.
Engineering is always about numbers, and when the first couple of requirements and the first level of requirements is usually not it's difficult to quantify as far as I understand.
It's a high level requirement coming from the market feedback, coming from market research, where we are targeting the vehicle. Who are we targeting with the vehicle? And those high level requirements you need to specify more and more.
Exactly.
So at the end you will have something which you can quantify, and
that's when engineers come in, because normally you want to engineer something to a certain quantifiable feedback and quantifiable review.
But I think from that point of view, the exterior design is quite an interesting place to be in, because you're receiving, I suppose, conceptual drawings, for example.
Yes.
And those are not really numbers. Those are just looks and visuals, and I can imagine the headache that you see some very, very fancy drawing which looks very nice, and you are like, oh my gosh, we need to implement this in real life, but how?
It's a teamwork, because how we start, for example, the exterior team or as well the interior team. So we work together with design on let's say they prepare the clay model. For example, obviously it is scanned, so we have a surface that we can work with in the CAD model. And in the CAD model, we start our feasibility studies based on the requirements we have, based on the engineering and other requirements we have. If it doesn't work, then we start the discussion again, where we can modify the surface, how we can change the design.
So you are not starting with the drawing, but they're making a clay model, and you are scanning it, and you are working with that surface afterwards.
It's a surface, yes.
Yeah.
Wow.
It's a Class A surface, which that's usually our input when we start the product design.
So it's you can call it a perceived surface, what the customer will see, touch, feel.
That's quite interesting to hear, because then the car begins its life by real hands, like a sculpture, and after that it enters the virtual space.
Yes. And it's actually sculpture, because as far as I know, the people who are responsible for these clay models usually are graduates of art schools, because that's
you can call them
sculpture. That's literal sculpture that they have to create there.
That's kind of amazing on its own, I think.
Mm-hmm. Yeah.
So it's a challenging process, but on the other hand, that's why we choose to be an engineer.
Of course, yes. Is there feedback between you and the design team that, for instance, when during your feasibility study something you find out something that it just won't go there? There is no way to realize it in the way that in the sort of in the way that the designer has dreamt it. What's the feedback process there like, or how close do you work with the design team?
So again, we are one team, even if they are in the design department and we are in the engineering department. It's one team, and our goal is to have a product, so we have to work together. But it's a good question, because a design is pretty much which shapes the car.
Yes.
To be honest, and engineering makes the feasibility, so we need to put all the effort to make that design feasible. And this is when innovation and new ideas
have to come to fruition, basically. Because
so
we would be the happiest if we could say design, that works. We can do that.
Yeah, but we don't give up, to be honest. When we first do the feasibility and it doesn't work, we don't give up on the first time. We do another loop. We try another technology, we try another process, we try another material, for example. Okay. Let's see if that works. So it's not... we should do everything in order to make that design, feasible.
And here you are already working together with a supplier who is going to produce that particular component.
There is a possibility for that, yes. Obviously, there are contracts between us and the suppliers. So, but there is a point when you can already involve them, based on their place in the market, based on their experience. what they have done for us already. So we got quite good relationship with our suppliers. So there is a chance that yes, we can involve them and make this whole continuous improvement of the design and make it happen. It's obviously easier if you involve them as soon as possible because their expertise means a lot.
And in the end, they are going to manufacture it.
And that's what I wanted to say. At the end of the day, they are going to manufacture the parts. So the sooner we can get feedback from them, the better.
Yes.
From a timing point of view.
When timing is everything, because
timing is really
start of production is start of production. That's that is the holy grail.
Yes,
that has to be.
Yeah, that's right. Because from time to time you need to target certain years for launching your car, because that can happen that the next year some regulation is changing. So you need to be prepared for that, and it makes a difference if you launch it now or you launch it a year later. So yes, it's.
Or maybe competitors show up. In the market, although. In your case, I think that is not a very easily definable area, so to speak.
And if you take one component, for example, a bumper or something like this, how much iteration loop it has when it starts to enter the CAD model from the clay model and until it reaches the serial production state with the supplier? Again, roughly, of course, no exact numbers are required here.
Let's say it can take. It depends on the content again, but the development, the virtual design or virtual development, it can take a year to do that. To do all the CAD work, do all the CAE work, do all the simulations, feasibility studies. Until we get a 100% feasible part, and then you have some. But when the design is reached, from your point of view, then you need to start the industrialization as well, which includes to manufacture all the tools, which which you use for every part. It's also difficult because it depends on the complexity, how many parts. For example, that bumper is made of, so you need to plan ahead. That's another, can take another 40 weeks, for example, to industrialize everything. And then when you get
almost as much time as the whole conceptualization until the
absolutely. And then once the industrialization happens, then obviously you get into the validation phase, which can take another 40-45 weeks to do all the validation, first of all, to do the design verification and the process verification, part approval.
Yeah, that's when we move on to the other end of the
right
V.
Side.
Yes. So at the beginning, until we get to implementation, basically that's when you get the first parts, and then from there onwards you go up in the other end of the V, pretty much.
Yes. And that's the validation and integration, and that's when we first start building cars, test them, and it's very nice to see when the first prototype car is built. To be honest, that's amazing because
were you there when the first Defenders? Oh wow, okay, that must have been a big moment.
It was quite a big moment, and it's always it's nice to see the product for the first time because you work 2 years before on that product, and finally
it's always just on your computer screen. So that's that must be understood that even though you have the really high-end visualization technologies nowadays and everything, but still you cannot touch it, you cannot grab it, you cannot. I mean, if you're an engineer, you like to do all of these things. Like you like to be in the physical exchange with the thing that you're designing, and that if that takes 2 years, that's a pretty patient job.
Although on component level, obviously you can use the rapid prototyping technology. So we used to print our parts and try them. Even we can do mechanical trials now with the rapid prototyping is evolving the technology itself.
Okay. Also, the quality is improving enough that you get
so results. you can do fit and function test.
Nice.
You can feel it, you can check it. Manufacturing feasibility you can even test. So a lot of good things coming out of those. But yeah, seeing the car first time on the line and being built, it's a good feeling.
Oh, I bet. I mean, I can only remember back to my times that I used to be part of a Formula student team, and David was as well. The first time when the car came together, it was just really. Normally we worked day and night on it, and then then when you see the whole thing standing in front of you, of course nothing works on it yet, but it's still there and it's still complete. That's a pretty special feeling.
Yes, of course, when hundreds of people's years of work is coming together for the first time, that's every time an emotional point in someone's life, especially if you have been involved into the process as well. I also have one question still for the exteriors. So again, we have spoken about quantifiable requirements, and that's not really the case here, especially for the looks. And I can imagine that from the concept drawings and from the clay model, some deviations are going to be made for the sake of manufacturability and industrialization. Who gets to decide that which modification is acceptable for the end product and how the end product will look like?
By modification, do you mean if a test is failed and we have to do a modification in order to meet with the requirement?
Not exactly, but we have all seen show cars and concept cars on fairs, for example, that when an OEM is introducing a new model, they are usually showing something very futuristic, which thing can barely roll, if it can roll.
Yes.
And after that, in a few years, it will be a serial production car, which barely remains for the concept drawing in just some small details maybe. And of course, a lot of deviation is made during that process in order to make it feasible in real life. And who gets to decide that what kind of ideas and what kind of elements of that original concept can lost and what will be implemented in the end?
It's a teamwork actually. So that's the center of competence, all the engineers, design, marketing, the program team, the chief engineers of the car. So it's really a team effort to make it as close as possible to what they dreamt of, but at the same time make it manufacturable and make it sustainable.
And not just what they dreamt of, but the potential customers dream of when they see the show car for the first time. It's a critical point to get it as close as possible. But
it is always cool to see concept cars. Not sure how you feel, but I love them.
Yes.
Yeah, it's
even though some of them cannot move or.
But still
pretty good.
But still, there are some really cool ideas on them.
Yeah.
So between that concept car, the clay model, and when it starts to materialize, there are a lot of loops, iterations, and a lot of discussions. And there is a certain point where you have to confirm your product definition, and that's where you say that yes, I can do this, I can make this happen, and from now on. We are working to this design. We are working to this solution, to these materials, and that's when you can actually start to plan how much the car will cost, for example. Yeah. Because you have an idea.
That's when you know what's going to be the content of.
You have an idea what will be the content. Yeah.
Yes.
How it's going to look like.
And I can imagine those are very hard decisions because you are not letting go. I don't know. 0.1 seconds of acceleration or gaining 20 extra kilograms. Somebody has to let go his concept of a look or something like this. And I can imagine that these moments could be quite hard and quite complex to decide. Yeah.
Probably heated discussions are going on.
Yes. Yeah. And that's usual.
And that part, yeah.
Especially when the team is passionate about the car that they are building.
About the concept and about the ideas or...
Yes.
Exactly. And so when we are looking at such a V model, your work is targeting which end of it usually? Where are you located on this map?
I think you can show it because you are closer to this.
So if you allow me. So we started here when we joined the company. The car was already in flesh, let's say. But now we are populating the left side of the V as well. We are giving feedback on the concept itself, on the requirements, So still, this is heavy for us.
Okay.
But we are working on the left side as well. Not just us, also our colleagues in the office who are working in other functions. But yeah,
it must be a really nice feeling that that now you can influence the future products. That's kind of what the ultimate goal is when you're in product development.
Exactly, and because we get, let's say every team member gained experience on the product. So I think a lot of people are they know that we have experience with the product. We know what works, what doesn't work. We know the suppliers. We know the requirements. Know the system. So I think it's good that we can influence some of the.
Yeah, I mean that's just if you have worked with the parts and if you have experienced some of the possible shortcomings or possible optimization opportunities that you have seen during your design, that's always really good to sort of feedback at the beginning of the design process, because the earlier that gets into the design process, the better the end product will be.
Yeah. So that's what we are targeting now, shifting our capacities to the left on the timeline. And obviously it's much more effective to have the same engineer starting from the concept phase until the launch of the car.
Yeah.
This is what I wanted to mention as well, that on one hand, from knowledge management point of view, it's very important that you have learned a lot from the previous designs and now you can implement these learnings in the new designs. But I also cannot imagine better way for a young engineer to start at an OEM than already have something on the table to experiment with, and also to open a new R&D location. It's a great thing to have, because how else would you teach for a complete new organization that how we are building a Jaguar Land Rover car? You can see that how the previous one is built and what mistakes have we made, what choices we made, and after that you can implement the same things. I mean, not the mistakes, but the learnings in the next cars.
Yes.
Yeah, as a lead engineer, that's one of the advantage to be, because it's absolutely not a boring job, because every phase is different. So you do the virtual validation and then the physical validation and then the pre-series build. So you don't do always the same. You don't always sit in front of the computer. Sometimes you, let's say, go to the supplier to check the manufacturing process, and then on the next day you go to the manufacturing plant to validate or test some cars. On the third day you may sit in front of the computer, do some CAD studies. So it's not a boring job, actually.
Doesn't sound like that at all.
Quite complex.
And you mentioned your role already, but you have also been, both of you have actually been in multiple different roles within the organization. As you progressed, what did you feel was the biggest difference between them, and how did this development help you go forwards in your careers?
When we joined, as we said, it was already you had the physical parts.
Yep.
But as always, they are not flawless from point zero. So you had to develop them. You had to change them,
test them,
and that's how we learned. That's how we learned the processes. That's how we learned about the company, about the manufacturing location. That's how we got to know our suppliers. So at the beginning, that was challenging, and then we learned about our commodities, let's say. So for me, it was seating. I understood the complexity. I understood the parts, the frames, the foams, the trims, everything. And then it's much easier to initiate new changes, to introduce new content in your cars. Obviously, you always change the car. The car is not the same for 10 years.
Yeah. Yeah, I mean that's also kind of a misconception, I think, in the customers' eyes, that we've been making this generation of this car for 5 or 6 years. So if you pick one from the end and one from the beginning, they're going to be the same cars, but they're not the same cars. There's many changes in between.
Usually not. Yeah.
Yes.
For me, it was a big change because I used to be a design engineer at the previous company, and then as a lead engineer, it's a different job. Also at an OEM, and I worked on a different component. But actually, that's it's kind of the advantage to work at an OEM, that because you you're not just work on a specialized component. You can change.
You're not going deep in one small area, but you get a breadth.
You can expand your knowledge on other commodities, other parts of the car, and that's what motivated me as well. And up until now, basically, to know more and more about the cars, have more responsibility as well. It's a good thing.
Very cool. Well, now we want to know more about the cars as well, I think. So we could move on, I think, to the
Let's dive
to
in
the
what
actual
Budapest has
product.
contributed into the new Defender.
What has Budapest contributed to the Defender, as David has already mentioned?
We had a lot of contribution to the Defender. As I mentioned, we most of us joined to the team when we saw the first cars.
The cladded.
Yes, I really like them, by the way.
The actual prototypes.
Especially when you see some of them on the streets, it's very, very amazing.
Yes.
For me. So from an exterior point of view, and I could put a name on each of the systems, but we worked on front bumpers, we worked on exterior ornamentation, glazing, lids, door systems, rear bumpers, claddings, lighting, and body structures as well. So it doesn't mean that we, as a Hungarian team, we did everything, because it was a joint team effort together with the UK team, obviously. But we had a big responsibility to deliver those components and let's say get an approval on the parts, test
Very
them,
nice.
develop them further.
What's included in exterior ornamentation? Because this is an off-road car, and that's not ornamentation is not really the first thing that comes to my mind when I think of an off-road car. So what kind of parts are included in that section?
For example, decorative plastic parts. As an example, not only decorative but functional plastic parts as well. They are all exterior ornamentations. For example, the plastic part you have on the hood, bonnet, or on the fender.
A hood and bonnet must be a
bonnet.
That must be a big point of discussion between the UK colleagues and you.
That's my mistake. I mean,
you didn't hear the word hood, no.
We'll edit it out.
We can cut it.
By the way, I never understood such kind of stickers on a prototype car, because it basically highlights that this is a prototype car and you should look and you should be curious. So
but
does it actually hide something?
It hides the shape. Yeah, it does. Really.
I mean, it's difficult to really reveal the details of the shape. I mean, I guess the large part of the car is going to be still visible, but at least the design highlights.
You cannot drive an unhided car on the roads, because then
you reveal everything before.
It's not a secret anymore.
Years before the product starts. I mean, for instance, the front of the car here on the picture that we are seeing on our screen is. I mean, naturally the logos and everything is blacked out, and then the headlights have different kind of covers, and the cooling ducts and everything. So
I especially like that on the front the logo is removed and covered, but on the side there is a 20 times bigger logo.
Well, I
small
guess
details.
But I guess this can also be used as a marketing exercise for the vehicle.
For me, but it still looks very good, and drive these cars is amazing. Test them. It's a very nice experience.
Is it nice because you have to go to the limit with them, or
It's
or
nice
just because that you're the first person, you're one of the first people who get to drive it?
Both, I would say. From a technical point of view, it's amazing because it's a new product and you are one of the first engineers to test them. And on the other hand, no one drove that car before, so
must be cool to be one of the first people to experience it.
And what was the biggest challenge in your career at JLR to make this happen? What was the most remarkable moment that you have lived through during the development?
At that time, I was working on the interior door trim, door systems, and door access system. I just put these CAD images in just to get an idea how complex a door nowadays is, because
just to relay that there's way more parts on the picture than one would imagine.
Yeah, because
there is more components.
They are assemblies, not sub-assemblies. So they are not sub-assemblies and not standalone components. So it's much more.
Okay.
Exactly. And so what I wanted to show here is that compared to old cars, nowadays even a door is really complex because you need to meet with a lot of requirements like design requirements, safety requirements, comfort requirements, and then you have customer requirements as well, legal requirements, manufacturing. Anyway, a lot of this.
That's just a list of things that you have to fulfill, and it's just getting longer and longer.
Just
by each,
on the doors,
each
it's about
product,
1,000 over than 1,000 requirements.
Really?
So
wow, okay.
And one of the key tests for the door system is the accelerated life cycle test, which means
is it a door shutting machine?
Door shut opening and closing machine, which is it's the cycle is more than 80,000 cycles together on different temperature, quite low temperatures and quite high temperatures as well. Humidity is involved also. So that was quite challenging because obviously the idea and the purpose of the Defender is to be durable, robust. So your door need to be robust as well.
Yes.
So that was very exciting when we started the test and when we completed. And even though we got good results, but we have seen some potential areas where we can further improve. So that took obviously some time to make those changes. But I think it was worth having that. So that I think for me that was the most challenging part of the launch phase, let's say.
And this sort of cycle test also simulates sort of forced closings, and like this is the kind of the maximum loading that the component has to carry.
You do measurement before the test starts. During the test, I don't know. As an example, the robot stops at 20,000 cycles. You do the measurements again, and also between the 0 and 20,000 cycles also, and then at the end of the test as well, and between that, you, for example, move the window down, move the window up, fold the mirror in different cycles. You measure the closing and opening effort. A lot of things are involved. And it takes, I don't know, maybe 3 or 4 weeks.
I mean, 80,000 times closing and shutting a door that's not something that you would want to do.
It's over than 8,000.
Automated, but still.
Yeah, it's still very, very exciting. And I don't think if a lot of people think that
a door is a door. I mean, what's complex about that?
In general, nothing special about it, but it is special.
Yes.
It is special, and it's
seeing that picture. I think it not will be very hard to pick one car from the 80s which has less component overall than this door alone.
I think I own a car that has less components than that. Looking at that picture, but yes, it's always startling to see this. And just going back to this test, do you have this testing facility here in Budapest as well, or was this carried out somewhere else?
No, it was. Okay. It was in the headquarters.
Basically, here you've got a kind of a virtual development office, when I can say that, or do you have any laboratories here as well?
We got small labs, and for other functions, for example, automotive driving guys, they have got testing facilities.
Nice.
They are actively using Zalazone, for example, for developing their systems. But majority of our physical tests are happening either at the suppliers or back in the UK at our headquarters, or on vehicle level in Nyitra. We got also shaker and climate chamber where we can simulate environmental loads.
Pretty high effort things to develop. So I guess that's why it's not distributed. I mean, it's not every location has its own.
Speaking about suppliers, on the car, what is made by Jaguar Land Rover on its own, and what is supplied by suppliers? So which are the key components what are still made by JLR? I suppose the chassis.
It's a difficult question from every OEM, I guess.
Yes, it's difficult. Obviously, the body structure is made by us.
Yeah.
We got a nice body structure shop in Nyitra next to the assembly line, and also paint shop. It's highly automated, as you can imagine. We got welding, for example, gluing technologies.
I mean, the structure is really advanced. It's whole aluminium body, if I remember correctly. Yeah. So that's right. that's as high tech as it goes.
Yes, as possible. Yeah.
I mean, on such a scale, obviously you could make it out of carbon fiber, but then probably wouldn't be able to manufacture so many cars.
I think a few OEM have tried this already.
Yes, and
they were not successful either. So,
but if you think about that from a financial point of view, it in a lot of cases, in majority of the cases, it doesn't worth manufacturing it for yourself. It worth getting it manufactured by suppliers who already has got the facility for that.
Exactly.
And it's already quite complex to assemble all the parts on the car. So it would make even more difficult to produce the parts as well. But it depends on case by case. Obviously, there are some parts which are made there. Many parts are not.
We touched that subject already, the complexity of such kind of automotive project to bring something in life with such amount of components, such amount of suppliers, the logistic, the manufacturing, the industrialization. That's from someone I heard that a car nowadays is the most technically complex thing that an average person can buy.
That's my knowledge level as
exactly.
well.
And this car is we are used to say that, come on, it's not rocket science, but it's even more complex than putting together than a simple rocket. So
I mean, it has way more lines of code, for instance, in the entertainment system alone.
And for example, a rocket is built for one use in most cases, not by SpaceX, but in most cases, yes. But a car like that has to go for like 20 years, and I don't know how many thousands of kilometers without an issue.
Exactly, and it's a very good point, to be honest, and this could be a good message to the future engineers as well. If you want some challenges, then you should work in automotive industry.
Don't do rockets. That's nonsensical. Just go for automotive.
No, I mean, because that's also a very interesting, but it's one of the most complex, let's say, product and produced in high volumes.
Exactly. That's the volume. The volume is the key there. That it has a lot of content in it, but it's also got to be made to the penny, because when you're producing something in a mass production environment, then cost is also a key effort, and
it is.
And that's less of a factor in the more specialized aviation or aeronautical parts.
One time I've met with one of my former colleagues who left the company for a consumer electronics company. And he was like, entering consumer electronics from automotive, that's a dream job. The requirements here, non-existent, basically.
Work for 10 minutes and then that's really cool. I mean, if you think about it, cars have most of the functionality of consumer electronics, and they also have to function as cars nowadays. So that's kind of where it comes from. Yeah, we've talked a bunch about the doors already, but let's just also move into the interior of the car, because we have some cool content on that as well.
So our team has contributed to all of these commodities in Defender. For example, the headliner, Viktor already mentioned the door trim, the climate system, the IP and the console system, the seatings, which I was also working with, the floor carpet and the cabin trim.
What IP means in this context?
Instrument panel. So it's one commodity with the center console, and it's one of the most complex commodity actually, because
I can imagine
you have to put in all the electronics, you have to put in the steering, you have to put in climate system. Actually, for example, in the armrest, you need to put in a fridge. In certain variants, you can option a fridge.
Right.
And you are putting in, as I said, tons of electronics to charge your phone, to connect your phone to the car. Plus, obviously, safety. So you have nowadays in the cars loads of airbags, for example, because you have to think on safety. Even in the seats, on the side bolsters of the seats, we got airbags. To protect the occupant from the side crash.
Okay. And of course, the seat already has a lot of functions with the electronics and the electric seat adjustment, and I don't know if ventilation or climatization is an option on the.
So in Defender we got a high range of options. So you can specify it from being a manual fore-aft seat with manual height adjustment and electrical recline, up to having everything electrical. So it's like an 18-way seat, for example, in Defender, where you got 18 options to adjust your seat fore-aft, up-down, cushion tilt, squab recline. And
I've always read this 18-way adjustable seat, and I cannot name 18 ways to adjust a seat in a car. So
that's because in the backrest you got lumbar, so you can move it up, down, sideways. You got the bolsters, which you can close and open to fit your back the most.
And imagine developing that.
Yes,
that's what I'm thinking. I'm just counting how many electric motors there are in a single seat, and then what it might weigh, because that might also be comparable to one of my cars.
It's a lot, although at the same time we make it as durable as possible, but as light as possible.
Exactly, because you cannot run away with weight, because that hampers the agility of the car.
Yes, and for example, in Defender you have memory front seats. Meaning that you got 3 memory options, and then the car adjusts the seats. I think the mirrors as well, right? And even the steering in the perfect position. What you already chose for yourself. So for that you need electronics. You even need a control unit for that. So it's quite complex.
It's just unreal, and I guess then each seat has its own control unit for each function, or
the front seats.
There are modules, I guess.
Yes, in the Defender, the second row and the third row seats are manual mainly. Okay. But for example, in Discovery, we also offer massage front seats. And
of course.
And electrical second and third row seats, which you can even control from the PV touchscreen in the middle. You can fold them down and fold them up.
That must be comfortable. It's just sitting in front and then you just adjust the seats in the back.
It's absolutely comfortable. But at the same time, we got heating, we got climate as well. We got sensors, for example, occupant detection sensors.
I think those features that you can remotely adjust the seats are mostly used when young and funny guys renting those cars, and they are just screwing with each other, then adjusting each other's seats.
and turning off the seat heaters.
Yes.
Hearing of all of these functions that are in the car, how difficult is it to sort of physically fit everything into the interior that is required to make all of these systems function, and like all of the electric motors and the heating and the cooling environments and the electronic packages and etc. So what are the logistics there?
Well, you already have to think about this when you start to develop the car in virtual environment, because you have to think about that the seat has to fit it through the door when you're assembling the car. For example,
not a small feature that the seat has to go through.
Yes, or even bigger, the IP.
Yeah,
and obviously it is being fitted with huge assistors to think of the human factors and the well-being of our operators.
But the good thing is that we have CAE simulations to
so
do all these studies before,
So I guess the proximity to Nitra is also helpful in this case, that you can exchange directly with the production planners.
So when you are doing a release, for example, for one of your parts, when you're doing the industrialization, then the manufacturing engineering already reviewing your design, and if they see that something is not right, it's not gonna work, then obviously you have to change it.
Do you have a memorable moment as well from your development? From the development of the parts that you were responsible for?
Yes. Can you go down 2 slides then, please? We got 2 pictures of a seat.
Okay.
As I was working in seats, that's the closest to my heart.
Well, that's fine.
So actually, in the seats, the most challenging is the complexity. These are just 2 front seats. The left side is for Defender.
Okay.
The right side is for Discovery. And obviously you have to fit all of these electronics, even if it's a function, or if it's not, then you're not fitting, obviously, but you have to make place for it if you wanna use that function.
And then in the end, the seat has to be comfortable as well, because you cannot just have the driver sit on a bunch of electronic boxes. So
yeah, that's right. So that's why you see on that that cut part that we got foams above them. We got the trims, but even the trims have got laminated foams on them. Actually, comfort is a good point, because we are already developing comfort virtually, because we got comfort curves. We are developing the seats to comfort.
I just wanted to ask that, how do you quantify comfort? Because at some point, I suppose you have to turn this into requirements in the end. So
yes, so what I mentioned, our comfort team is actively working with the design team together to create the surface what you perceive as a customer. And you can quite well define it with comfort curves. And
what does a comfort curve say actually, or what does it contain?
It defines.
Is that the shape of the seat, or is that some sort of a function of
the ideal shape
of
of the surface? Yes, where we got even virtual mannequins, which we can put into our models, and we can validate how the occupant will sit in that car, children and adults as well.
And quantifying, you can also define the density of the foam.
Yeah, all of this is.
Imagine also some displacement curves, that how much displacement is allowed when.
Yes, we got reference points. We got all of this, and already in virtual environment we can define a target score. We are scoring it, and when it's in physical form, then we are evaluating it with multiple colleagues, with mannequins. We are doing surface pressure testing to see if you have hard spots, for example. Can you feel the structure somewhere through the foam? Because if you sit in, you might not feel it, but through a 3-hour drive, you will start to feel it. And all of these we need to see already at the beginning of the development. So yeah, and on top of this, we are offering all these cars with different trims. So with leather, with fabric, with certain kinds of polymers on different panels. So that is giving the challenge to develop and make the seat fit for all of these purposes and all of these options.
Is there does one of these materials have a particular difficulty to work with, or?
Yeah, certain materials are easier to trim, let's say, than the others. It has got the same shape. You got different options, for example, for the foams, because one has to package even the climate system. So when it's heated and cooled, the seat itself, you get a different foam for that, because you have to let the air through the foam. So yeah, it's quite a challenge, obviously, and fortunately, let's say, our customers like the leather variants. We were working a lot on those to make them as durable as needed.
So the durability was there a particular challenge?
Absolutely, yeah. Okay. So as Viktor said, for doors, we are also simulating the life cycle load with, let's say, ingress-egress. So it's a robot actually who is sitting in and out into the seat and checking at the end how the trim looks like. Did the foam experience any damage or any wear? So yeah, it's a long process, and you have to think about all of these aspects. And just one remark to the rear seats, because that's I can say even more complex in Defender, because we got the 90, we got the 110, and we got the 130.
That's exactly what I wanted to ask. Is that do you consider that like all of those parts as a whole package, or do they belong to different people who are responsible for them? Because
no, it's one, let's say, one commodity. Okay. We got multiple engineers working in this commodity. But for example, the 90 has got a different design of seats than the 110. And even in the 110, you can have different rear seats, because if you have a third row seat, then you have a tip and slide seat. If you don't have third row seat, then it's a fixed seat, which you can fold, where you can fold up the cushion, and you can fold the squab flat, completely flat. So making you a quite big load space.
Wow, it's just the variety is just insane. I mean,
It is.
how many different variants do you have to develop when you think of all of this?
Well, let's say that for in Defender you can get with 2 seats, 3 seats, 5 seats, 6 seats, 7 seats, and 8 seats.
Okay.
And different colors, different
and then different
Yes.
colors, different materials, and then on top of that comes the whole electric adjustability and the
Yes,
climatized
exactly.
seats and everything.
And just one more remark, that at the same time you have to think about the sustainability as well.
That's what I wanted to ask with the leather as well, that you mentioned that today sustainability is a huge factor in automotive, and that touches also the interior because of the leather, sourcing the leather. How do you cope with this challenge? And
Well, we got obviously variants which so for example we got a variant where the center of the seat, the center panels are Alcantara,
okay,
which are made of minimum 30% of recycled PET, for example, or recycled fabrics. And of course, all of these components have their life cycle, and there is a certain amount which has to be recyclable or coming from a recycled source. Yeah. Let's say.
But leather itself is still leather, so it's not.
Yes.
It's not vegan. It's not.
It's not vegan, but we have our materiality option, which is which doesn't contain any animal resource.
But is that also leather-like, or is it more fabric-like, or it's
Both,
kind of
actually.
in between? Okay.
We got both. So we got a leather-like polymer cover, and we got fabric-like covers as well. So the customer can choose which one they want to.
I mean, the individualization is just a huge deal now.
And even if I can turn to Viktor, the exterior of the car, so for example the body structure has got a certain amount of recycled aluminium in it.
And also the plastic parts.
Yeah.
That must influence also the sort of the material choices and the requirement fulfillment of the parts, I guess, that you have to take into account all of this.
And it makes the development even more difficult, because the characteristic of the recycled material is pretty different than casual plastic materials. So your injection molding parameters will be different. Your, let's say, the capability of the part will be different. So it's a different.
It's another factor that you have to take into account.
Yeah.
Speaking still about the leather stuff in the seats, for example, are you designing a surface seat as well, and the supplier is designing the layout for the leather, or are you designing the layout and the carpentry as well? Because then it's here we are again on a borderline profession between mechanical engineering and carpentry, basically. So
so we are giving the surface what we would like to achieve with the seats. The supplier obviously reviews it for feasibility, and together with them, actually it's a joint effort. We are developing the covers. We are even defining the sewing lines.
Does it influence comfort as well?
Yes, because you can imagine that if you put it in a wrong place, you will feel it. That something is pushing your back, because there is a sew line there.
Yeah,
so
nice.
It has got mechanical and also cosmetic.
It's just amazing how many factors go into all of these aspects of cars as well. And in the end, all you feel is that you're sitting in a really comfortable and nice space. But all of that has a lot of science behind it. It's not just because somebody accidentally made it like that, but there's way more to it than that.
It's not sheer luck; it's development.
Yes.
No, if you do something accidentally or in luck, that's not proper engineering.
Exactly. But I think what's really nice here is that I think comfort is something quite abstract. It's quite difficult to connect with numbers, and yet that's what you have to do. And and this is how really comfort can be engineered into the car. And that's something that shows the complexity and the level of the automotive industry
but
of today.
Even if you engineer it, at the end of the day, a lot of seniors, for example, are sitting in the car checking it, and they will have their opinion. So it can happen that someone will feel it less comfortable. That can happen that someone will feel it, it's really comfortable. But we have the science behind it. But it changes from person to person.
Exactly.
How you perceive all of this.
Can you quantify or parameterize how a Defender feels and how should a Jaguar Land Rover car feel? Or there are just senior peoples there who are knowing that how a Defender feels in the past 50 years and they get to decide that, yes, this is our brand and this is what we are going to the market with.
Obviously, there is a strategy behind all the products, so it's not just a one-person decision. It's part of the strategy, how the Defender should be, how the Discovery, how the Range Rovers, Jaguars. So it's they all of the models have their individual
characteristics and parameters.
Strategy and view and everything.
One of the difficulties must be that with such a broad product portfolio, it's sort of compartmentalizing each of the projects must be a huge task of its own at the beginning. And I guess that you are also working on multiple projects. I guess then you also get a taste of it when you get your requirements.
Yes. Yeah. Now, both Viktor and myself are overlooking and managing the exterior and interior team. So, for example, in my case, it's also the cockpit itself. And also there, I can mention Discovery, where you have 5 compartments in the instrument panel and the center console. So it's you have your target, you have your vision, what you want to do with that, and that's how you are developing it. And those functions has to be unique because that's what is selling the car.
Exactly.
Yes. And in the end, I think it's not a bad if there is some person, it's not necessarily one who is in the end needs to say that this is what we are going for and this is what we have looked for, because in the requirement sheet there are just numbers, and you can feel if a car made by persons and made with passion.
That's
and
what
in
I
the
wanted
end
to say. Yes.
by decided that
And
yes, this is it.
What I can see at JLR is that honestly, all the people who work on these products are passionate about, and the decision makers as well. So it's really a passion for us, these cars, because they are unique. They are really unique.
Still up today, when I see a Defender on the road, I feel warmth. Really.
Yeah.
Yeah, that shows the passion that goes into it, and I guess that kind of shows the company culture as well. That we also want to touch upon a little bit. That really this passion shines through right down to the products. Just can you give us some memorable experiences that you have had while working at JLR? I think we've got time for 2 maybe.
I've got a very good example on that. When we launched the Defender, we worked really a lot in the plant to test it, validate, develop it further, and it was late night when we were still in the plant, and we were sitting in a meeting room with one of our leader, and he tried to motivate us. He said that, I know guys you are tired, I know guys you work hard, I know you do everything to make this happen. Just think about when you see these cars on the roads, and you will feel that it pays out, and that's what we feel nowadays. That when we see the car on the road, it's very
it feels with pride. I guess
very good. Yes.
Yeah.
So I will never forget that moment. To be honest, it was really, it motivated me pretty much.
That's nice.
Yeah, and also because it was a very good team there, including the UK team, the Hungarian team, and the Slovakian team. So on one hand it was challenging, on the other hand from an engineering point of view it was really good to learn a lot, but on the other hand it was a good team building as well.
Yep.
That's why we have a very great team in Hungary, and
I can see you smiling. I guess you're on the same opinion.
Yeah, absolutely, absolutely. So
overcoming challenging together, it's the best team building event that you can have. So
yeah, and we always helped each other. So if I was struggling, the others were always up to help me.
Yep.
If they were struggling, we were always up to help them. It was
And actually, when we joined, then even the plant itself, because it opened earlier a bit than the office in Budapest, but the Nitra plant also opened It was quite young then, in 2018, I think. I don't want to say anything incorrect. And so the plant was new, the people were new, the process was quite new, although they brought here the Discovery production already running in serial. So we were there, and we had to, obviously in pre-serial builds, you got issues, you got problems, and we were there.
That's why it's called pre-series.
Yes, and you are there, and you have to solve it because you don't have the time and the luxury to stop. So you have to solve it on the spot. So, for example, one of my memorable moments was when we joined with one of my seating colleague. As engineers, we were drilling metal frames in the plant. In our second week, because we had to fit them. So
that's just what had to be done.
As a lead engineer, you need to be. Sometimes you need to know how to solve problems. Problem solving skills are quite important. So if you need to drill something on the part, you need to drill something on the part, and you need to know how to do that and with what to do that. So it's not only, as I said, it's not just sitting in front of the computer. Making models, you also need to know how to use the tools.
Be hands-on.
Yes, you made your hands dirty because you had to solve it quickly, and on the other hand, you had to define how to solve it in production. What to change on the part itself to make it work. So it was engineering as well, and handwork as well. So it was quite challenging, but memorable, really.
That sounds like you have. You both have made your marks on the Defender, and the Defender has made its mark on you.
Yes.
I guess. Amazing. It was really cool to hear all of these contributions, and now I'm definitely gonna look at the Defender with different eyes from here onwards.
Just one note. So I think all the team members could tell. A different story as well, because they had different challenges. So it's just our
loads of these stories happen there. But
do all the engineers also have sort of this proximity to the product, and do they also work quite closely with the end product? I mean, with the finished vehicle.
In our area, in body engineering, where we are in product development, yes, we can say they are frequently visiting the plant and checking actually what they have done. Mm-hmm. There are certain areas which are more office based, obviously, but we have got the fortunate situation that yes, we can touch what we did.
Nice,
and that makes it enjoyable for us. So.
Yeah, cool. Well, I think we could continue this conversation for quite a while, but we are
and we actually will.
We will, David. In what form?
In podcast form, or.
Yes. That's what I meant. Yep.
My point being is that with JLR we are going to continue this podcast series. Unfortunately, not necessarily with you, but with other colleagues. We are certainly going to have more conversations. And speaking of JLR and speaking of 4th of July, we have one event coming up in a little bit more than 1 month, which is
Formula Student East, which is the main event of our association, where, of course, you guys are more than welcome to attend, and I hope that you already planned it in your schedules.
Welcome, mandatory. JLR is our main sponsor.
Pretty much.
I've been there last year as a judge.
Nice.
And what I experienced there was amazing. The students there are just they are very skilled, and what they do is very, how to say, it's just amazing. Honestly, the cars and the effort they put in, that it's very good.
They are the future, so we have to walk there with open eyes, really.
Definitely, and not just you, but all of our guests and listeners are also welcome to attend, because we are opening the gate this year to visitors as well.
Of course.
And of course, once you are there,
and János will make quite nice guides for the visitors to learn and enjoy about Formula Students.
When does the event start? How much time do I have for that? But yes, of course,
a few weeks.
Yeah, we'll.
There are the evenings too. Yes. So
and sleep is for the weak anyway. But yeah, we'll ensure that everybody has an enjoyable experience at Formula Student East, and I think one of the big contributors is going to be the stand of JLR, because you will be present on site with staff and some amazing vehicles as well, as far as I know, and I cannot wait to see this collaboration come to fruition on the Hungaroring.
Yeah, we can't wait to.
It's going to be a pretty amazing week. We have to recharge our batteries before that, David, but I think it will all be worth it in the end. So it always is, and we are at this point naturally very, very thankful for JLR's support in our cause. It's amazing to have you on board, and it was amazing to have you here in this podcast. So
I think it's great to support a great community like Formula Student. So.
And thank you for the invitation.
Oh, that's absolutely that is not even to mention, and I think you have formulated it much better than we ever could. Why it's worth sponsoring.
I think we can say that you are always welcome for various reasons, for the passion about cars, for your experience, for your stories about the industry. So.
Okay, we will tell the others and we will send them here.
Great,
thank you very much.
The more the merrier. Yeah, thank you very much for being with us, and thank you to our listeners, viewers, everybody who has been following us in the past season, because this episode is special not just because of our guests and because of our topic, but also because this is going to be the closing of the second season of Behind the Blueprint.
Indeed. As János mentioned, we need to recharge our batteries before Formula Students, so
this is our last recording. The episode will go live just before the event, so make sure to check out our social media channels and our webpage, fseast.eu, and Formula Student East on Instagram and Facebook, and on LinkedIn we are under the name of the association, so Association of Automotive Engineers. All of the relevant information is going to be posted there. You will be able to keep up with the teams, keep up with our fantastic sponsors, and keep up with what's going on behind the scenes as well.
And when we are going to come back?
We will be back in the fall. Let's be in the fall. Let's be diplomatic enough.
Okay.
So we'll be back. That is for sure. And until then, have a nice summer and see you at Formula Student East. And thank you very much for
thank you very much
being here.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.
Bye everyone.